the coldest phase of water is ice. If I go to my freezer, we see solid water, H2O solid. The temperature in my freezer is negative. It's at negative 15 degrees Celsius. So the ice in here is that cold. When ice starts to melt, you get a mixture of liquid and solid. And the liquid can only exist at temperature 0 degree and above. That's the melting point of water. The solid can only exist at temperature 0 degrees and below. So if you're going to have a mixture of liquid and solid, which you get when you're melting ice, the temperature has to be 0 degrees Celsius. So you can see my thermometer is maybe a little bit off, but that is the temperature at which you can have a mixture of liquid and solid water. Now the amazing thing about this transition, this phase transition, is that I've got my hot plate on. The temperature's still cold in the beaker. It's going to stay at this 0 degrees Celsius temperature until all the ice, all the solid, has converted to liquid. As long as I have solid ice in the mixture, it's going to keep the temperature ice cold. Liquid water can exist at any temperature between 0 degrees Celsius, that's the freezing point, and 100 degrees Celsius, that's the boiling point. So now I'm heating up some liquid water. You can see it's getting pretty hot, 89.1 degrees Celsius. Going to come back in a couple of minutes to see if it's boiling. Not yet boiling, but you can see the temperature is rising. I put a lid on the beaker to help keep the heat energy in. Alright, so now the water is boiling. If everything were perfect, my thermometer would read 100.0 degrees Celsius. So it is a little bit off, but you can see that's the temperature. Now if I remove the lid, then you can imagine, and you can see, I think you can see, that the water is vaporizing. There's steam coming out of the beaker. So it will stay at 100 degrees Celsius until all the water has turned into gaseous water. Water vapor. Here's my last part of the cycle. I've got my thermometer trying to measure the water vapor. I'm not doing a good job of it. In reality, the water vapor is hotter than my thermometer is reading, but there's a lot of air there and the air is cold, so I'm getting an average reading. There is no upper limit for how hot the water vapor can become. It can get to be 120, 130, 250 degrees Celsius. No upper limit for water vapor, H2O gas.